Richland, Washington, a community of 50,000 people located 200 miles east of Seattle. It is also home to InEnTec, founded by scientists and engineers from MIT, GE, and Battelle, and the creators of the plasma-enhanced melter. Efficient, effective, environmental. The plasma-enhanced melter, also known as the PEM, answers two pressing needs: the growing demand for clean, renewable fuels, and the increasing call for the safe disposal of the overwhelming amount of waste produced every day. Rather than burning waste like an incinerator, the PEM technology converts waste into environmentally safe products while complying with EPA emission standards. The Richland PEM can process about 20% of the city's municipal waste. That's 25 tons of trash per day.
The plasma-enhanced melter can accept a broad range of waste materials, including hazardous, industrial, medical, all the way to municipal solid waste.
The PEM converts waste to clean fuels and other products in a multi-step process. First, the waste enters the pre-gasifier. Here, partial oxidation gasifies some of the waste. The partially processed waste then drops into the PEM chamber, where it lands on the surface of a molten glass bath. There it is heated by an electrically generated plasma arc. Inside the plasma arc zone, the temperature can reach more than 10,000 degrees. These high temperatures break the chemical bonds, allowing the atoms and molecules to be recombined and converted into useful materials. The inorganic compounds dissolve into the glass bath. The metals are drained from the bottom, producing a recyclable alloy. All of the other inorganic material is combined and chemically bound into a glass-like substance, which can be used in a variety of building and construction materials.
The amount of waste that it would take to make a glass chunk this big would be approximately the size of a large SUV.
But most of the waste fed into the PEM is converted to synthesis gas, the basis for clean, renewable fuels. First the gasifier and then the plasma arc release hydrogen-rich synthesis gas from the organic material in the waste. The synthesis gas is then passed through a multi-step cleaning process. The synthesis gas, rated as ultra-pure, can be converted into ethanol, hydrogen, and other fuels. In 2003, Kawasaki Heavy Industries purchased a PEM that it has used in Japan to demonstrate the destruction of PCBs and asbestos. Now it is pursuing large-scale commercial projects using the PEM technology. The Taiwanese company Global Plasma has been using a PEM since 2005, converting medical and industrial waste into clean electricity. And in 2007, Dow Corning signed a 10-year contract to use InEnTec technology, reducing their transportation and disposal of 20 tons of hazardous waste a day and creating enough synthesis gas to heat 3,500 homes each year. The plasma-enhanced melter is changing the way people think about waste and about renewable fuels.
The PEM could reduce our dependence on foreign oil because, for example, if we converted all of the waste that's generated in the United States in a year, we would produce approximately 50 billion gallons of transportation fuels.
The plasma-enhanced melter is keeping pollutants out of our groundwater and reducing dangerous emissions into the air. It's preserving valuable food crops and converting our waste into a wealth of clean, renewable fuels.